As we know, mensuration has two major parts, plane figures and solid figures. And today I start solid figures. Here is part 1 of the topic solid figures. It deals with volume and surface area of solid figures. In this video, part 1 of solid figures, I'll discuss about cube and cuboids. Let's start. Before I start, there are some terms related to the topic to be discussed with. The first word is solid. The definition says anything which occupies space and has a definite shape is called a solid. A solid is a three-dimensional figure and it has three dimensions: length, breadth, and height. The next word is volume. The definition is the space occupied by a solid is called its volume. The next word is capacity. Capacity means the internal volume of any object. Here the definition is the capacity of a container is equal to its internal volume. The next word is volume of material. This means the volume of materials used in constructing an object. Next, the volume of material used in a solid body. The statement says the volume of material in a solid body is its external volume or total volume. Next, the volume of material used in a hollow body is the difference of its external volume and internal volume, because any object which is in the form of a container, it has some thickness. Next one is surface area. The sum of the areas of all the surfaces of a solid is called its surface area or total surface area. Let's discuss cuboid. The definition is a three-dimensional rectangular solid having six faces, each of which is a rectangle, is called a cuboid. Volume of a cuboid. A cuboid has three dimensions: length, breadth, and height, and its volume is the product of all these three dimensions: length multiplied by breadth multiplied by height. Next is diagonal of a cuboid. The definition is the length of the longest straight line that can fit inside a cuboid is called diagonal of the cuboid. And mathematically, diagonal of the cuboid obtained using Pythagoras theorem is under root the sum of the square of length, breadth, and height, that is under root L square plus V square plus H square. Next word is total surface area. As we discussed earlier, that all the faces of a cuboid are rectangles. To find the total surface area of a cuboid, we find out the area of all the rectangles available as surfaces of the cuboid. The next word is lateral surface area. The definition says It is the sum of the area of four vertical rectangular faces of the cuboid. It means out of all the faces of a cuboid, except bottom and top, is the total surface area minus the area of bottom and top horizontal areas. Hence, the surface area of the cuboid, except floor area and ceiling area, is given here in the form of a mathematical expression, and that is 2 multiplied by length into height plus breadth into height. Observe the cuboid drawn here. In this cuboid, this horizontal line is its length, and the next horizontal line shown here is breadth of the cuboid, and this vertical line is called height of the cuboid. Let's discuss a cube. According to the definition, a three-dimensional rectangular box with six faces, each of which is a square, is called a cube. It means in a cube, length, breadth, height are of same length. Next is volume of a cube. As we know that a cuboid has three dimensions, length, breadth and height. Here too in cube three dimensions are there, but all those are equal. Hence directly we can write volume of a cube is edge multiplied by edge multiplied by edge, that is the cube of the edge. Next word is diagonal. The length of the longest line that can fit inside a cube is called diagonal of the cube. Formula for the diagonal of a cube is obtained using Pythagoras theorem. The result obtained is root 3 multiplied by a. It means root 3 multiplied by edge of the cube. Next is total surface area. As we know, all the six faces of a cube are square. Hence, the total surface area of a cube is 6 times the area of the square. So that is 6 into a square, where a is the edge of the cube. Next is lateral surface area. According to the definition, it is the sum of the area of all four vertical square faces. It means lateral surface area of a cube is total surface area of the cube minus the sum of floor and ceiling. Mathematically, the lateral surface area is 4 times a square, where a is the edge of the cube. Now observe the diagram drawn here, where this particular line is called length of the cube. This another straight line is called breadth of the cube, and this vertical straight line is called height of the cube. Let's take some questions based on cube and cuboid. Here is question number 1. The question says the dimension of a solid metallic cuboid are 72 centimeter into 30 centimeter into 75 centimeter. It is melted and recast into solid metallic cubes with each of edge 6 centimeter. Find the number of cubes formed. Since a solid cuboid is melted to form cubes, hence the volume of cuboid is equal to the volume of all the cubes formed. The reason behind is, in both the cases, volume will remain same. The expression obtained for the number of cubes formed is 72 multiplied by 30 multiplied by 75, where 72, 30 and 75 are the length, breadth and height of the cuboid, and 6 multiplied 3 times is edge of the cube. The result obtained after simplifying this expression is 750. Hence, the number of cubes formed is equal to 750. Next question, question number 2. The internal dimension of a box are 40 centimeter into 30 centimeter into 20 centimeter. Find largest number of cubes which can be placed in the box if the edge of the cube is case 1 3 centimeter, case 2 4 centimeter and case 3 5 centimeter. Here the solution given below is for number 1 where the edge of the cube is 3 centimeter. Since volume of the box divided by volume of the cube doesn't give the result in whole number, then the process is different, and that is number of cubes that can fit along the length of is equal to quotient of 40 by 3 and the result is 13. Means along the length of the box only 13 cubes can fit and a bit space will be left where cube cannot fit. The number of cubes that can fit along the breadth of the box is equal to quotient of 30 divided by 3, and since it is completely divisible and the result obtained is 10, means along the breadth 10 cubes can fit and leaves no space. Number of cubes that can fit along height of the box is equal to quotient of 20 by 3 and the result is 6. Now here 20 by 3 is not a whole number. Then along the height of the box 6 cubes fit and a bit spaces will be left. Now total number of cubes that can fit in the box is equal to 13, that is the number of cubes fit along its length, multiplied by 10, that is the number of cubes fit along its breadth, multiplied by 6, that is number of cubes fit along the height of the box. Finally, the answer of this product is 780 and it represents the number of cubes that can fit in the box. Next question, question number 3. The length, breadth and height of a rectangular solid is in the ratio 5:4:2. If the total surface area is 1216 centimeters square, find its dimensions. Since length, breadth and height of the cuboid are in the ratio 5 is to 4 is to 2, hence we assume length as 5x centimeter, breadth 4x centimeter and height 2x centimeter. Here x is the ratio factor. According to question, total surface area is equal to 1216 centimeters square. In the second line, the total surface area 1216 is equated to the formula for total surface area, and it is simplified to get the value of x, and x comes 4 centimeter. This ratio factor x equal to 4 centimeter is used to find length, breadth and height of the rectangular solid, and length, breadth and height obtained are 20 centimeter, 16 centimeter and 8 centimeter respectively. Next question, question number 4. A tank 20-meter long, 12-meter wide and 8-meter deep is to be made of iron sheet. It is open at the top. Determine the cost of iron sheet at the rate of rupees 12.5 per meter if the sheet is 2.5 meter wide. Since the tank is open at the top, then the total surface area is the lateral surface area plus area of the bottom, and the result obtained after evaluating this expression is 752 meters square. So total surface area of the tank except the top one is 752 meters square. Now, as we know, total surface area of the tank is equal to the total surface area of the sheet required, and since the width of the sheet is given, that is 2.5 meter, hence the length of the sheet required is total surface area of the tank divided by width of the tank. The length of the sheet required is 752 divided by 2.5, and finally the length of the sheet required comes 300.8 meter. Next, the cost of the iron sheet is rate of the sheet multiplied by length of the sheet required, that is equal to rupees 12.5 multiplied by 300.8 meter, and the final result is rupees 3760. Or after finding out the total surface area of the tank, we could have directly written this expression to get the answer 3760. Part 1 of the chapter Solid Figure is over. In this part, I discussed volume and total surface area of cube and cuboid, and some questions too are taken. Apart from that, some real life problems like volume and surface area of walls of a room and the cost of preparing that at a certain rate are discussed, and melting a certain object in the form of cube and cuboid and manufacturing a set of another cube or cuboid of different dimensions. Well, you prepare this chapter. Some other questions too you take from your prescribed book. Thank you.